Hello, my name is Gabriel. I'm a mechanical engineer, and we are at Attila, this amazing roaster manufacturer, to talk a bit something that people usually don't talk too much. It's about the thermocouple, the probe that gives us the temperature reading and some, let's say, misconceptions that we have. This kind of probe, the thermocouple, it's on the majority of the machines that we have on the market right now. If you are an experienced roaster, sometimes you notice that even if you perfectly follow your reference curve, you follow the temperature versus time, and you follow your ROR curve, even like this, sometimes your sensory profile it's different. It's a thermocouple limitation. Sometimes also a common mistake for beginners is to get one roast made in another machine, and people say, oh, come on, give me your curve. I'm gonna put on my machine. Even for the same coffee, it's not gonna work because of differences that machines have. The thermocouple will read different temperatures. Or other things that you might note, if you're more experienced again, is when you're doing different batches, different size of batches, the temperature for a small batch, the final temperature, it will be different than a bigger batch. So you're gonna adjust this final temperature. Those are all thermocouple limitations. So why this happens? Our goal is to measure the bean temperature, and yeah, the probe is there on the beans, trying to get the conduction temperature when the beans touch the tip of the probe. But try to imagine this already. You have different temperatures on the beans because some beans are coming from the drum, some beans are coming from the middle, and they have small differences of temperature. And they are already touching the probe, but they are different, so the probe gives us an average of the temperature, so that's okay. But now, try to imagine a big mass. You don't have only the beans there. You have also the radiation from a lot of parts. You have some conduction from the other part of the stick of the probe. But mainly you have the convection from the airflow, and that makes a huge difference for us. Well, I had to change the place. I had to redo the end of the video. The rain was too high, so let's continue. So we are not really measuring the bean temperature. We are actually measuring an average of my whole environment. So all those heat transfer that I mentioned are making an influence at the temperature that my probe is measuring. That is really important to understand. And as soon as I change my airflow speed, my reading of the thermocouple is gonna change as well. So that is the difficult part to understand. So going back again, this airflow temperature is not the same temperature as the bean. So if you have a perfect bean or a device that you could measure the real bean temperature, it will be different than the airflow temperature. So we are actually not measuring the bean temperature, we are measuring an average of the environmental temperature inside the drum. So as soon as I change my airflow speed, and that is really important, as soon as I change my airflow speed, I'm changing the reading of my thermocouple. So I'm not changing the real temperature in the beans. Of course, it's gonna change a bit, but mainly I'm changing the reading of the thermocouple when I change the airflow speed. The same happens when I change the batch size. Why? Because it's gonna change the way that the air is passing through the beans. So that is why it's so confused, because the thermocouple don't give us the real temperature in the beans, so gives us an average and is highly influenced by the airflow speed. So my advice is, the airflow is a really good tool to control the roast. So when you're going to create a roast, you can use the airflow to control the speed of the roast. You can use the airflow to control the ROR, just like you use the gas. So if you're creating a roast, a curve, you can change as many times as you want. But when you're going to reproduce that curve, keep the same airflow as you used at the reference. In this way, if you do this, you don't know how much you change the reading of the thermocouple. But you know, if you keep everything the same, you're gonna read the same way. So you're gonna have consistency. So in another way to see, if you do a reference and then when you're going to reproduce this roast, if you change the airflow that you used at the reference, actually you're roasting using as much as you're reading the same temperature. The real temperature in the beans, it will be different. So that is why it's gonna cup different. So other thing that, if you're an experienced roaster, you might notice that in rainy days, the roaster behaves different from drier days or drier seasons. It's because the coefficient, the heat transfer coefficient, it's going to be different because the moisture of the air. So you have this difference because of the velocity of the fluid, the air, and you also have this difference because of the moisture in the air. It's more difficult to handle because different from the airflow speed that we can control, the moisture in the air is more difficult to control. We try to roast in a controlled environment, but it's impossible to control everything. And there comes other thing. The inlet air that is getting your drum, it will be affected by the temperature of the day. You're gonna have this air getting in your drum. Some roasters, it will pass through the flame, get some heat. Some roasters might not pass through the flame. So anyway, this air is gonna get in hotter or colder depending of the temperature of the day. So again, it's gonna affect the reading of my thermocouple. Of course, just like the moisture, it's gonna affect the response of my machine. It's gonna affect the way I have to handle my machine to follow the curve, to follow perfectly the curve. And also, it's gonna affect my reading of my thermocouple. Again, just like the moisture, it's more difficult to control the environment. So about now, you might think that the thermocouple is measuring wrong. No, it's not. It's perfect as soon as you keep the variables the same. But you know now that some variables you cannot keep the same. For example, the airflow, okay, we can control. Right, good. The batch size also we can control. But the moisture and the temperature of the room is more difficult. And then the thermocouple is gonna measure wrong. But if you could keep everything the same, the thermocouple would be perfect. And by now, if you still don't believe me, just do a really, really simple test. Just put two thermocouples at the same drum, closest as possible, let's say 2 centimeters from one to another one, and you're gonna see different of the readings of the temperature. So you start to ask yourself like, well, they should be the same. The coffee is the same. The mass is moving. I have I don't know, 150 degrees in one, 160 at other one. Which one is the right one? Both are right. Both might be right. You just need to choose one and follow one. So sometimes you can see 10 degrees, even more degrees of difference between those thermocouples, and it's not linear. That is why it's so difficult to create rules. So everything that I said, you cannot create a compensation for the probe. You cannot just put, let's say, every 10 degrees or every 10% of moisture. Just consider 1 degree, more or less, I don't know, at your probe. We cannot create this rule because it's not linear. It's a little bit more difficult than this, and there's some more variables that is more difficult to handle. And with this simple test, you're gonna note that thermocouple changes even with the position. So be really careful when you're going to clean your machine. Sometimes if you move a little bit the thermocouple, also you can make a difference between your profiles. So if you create a profile and you change a little bit your thermocouple position, you're gonna have to adjust some degrees of your roast. So how to make this adjust? Usually you get your first roast of the day, a coffee that you know well, and then you do a roast. Try to copy the last profile that you made, and you're gonna feel that usually by the weight loss, if you lost less or more than you should, you're gonna adjust some degrees more or less in the next batch, and of course you're gonna feel the change between each batch that you're making. And of course during the day, the weather, the room is gonna change a bit, and you have to make some adjustments. So that is why it's so difficult when we change the machine to keep the curves that you have. You have to change the curves, actually. You have to create new curves, because all the reading of the new machine is going to be really different. So that is why when you change the size of the batch, you have to do some adjust at the temperature, of course, the profile again, the curve, the whole curve, but mainly at the temperatures in the end. That is why it's so difficult it's impossible actually, to ask your friend, your neighbor, profile and just put in your machine. You have to do some adjusts. And this is all because of this limitation of the thermocouple. It exists. We have to know how to handle it. First, we have to know that exists, and then we have to handle it. So thanks for watching. I know it sounds a little bit confusing, this subject, because it is. I think it's the most difficult thing that I say. Usually in the course that I provide, I don't even go really deep on that. It's better when you already have some experience and you realize that you find some differences. Thanks for watching. See you.